Hello and welcome to another video. Now let's prove that this expression, when simplified, okay, it will be equals to 4. Okay, so this is on the left hand side, so this is the right hand side. Okay, so we want to prove that when we simplify this expression on the left hand side, we're going to get 4. Okay, so the left hand side, we have that the left hand side equals parentheses 81 raised to the nth power multiplied by 3 raised to the power of 5 minus 3 raised to the power of 4n minus 1 parentheses 243 all over 9 raised to the power of 2n multiplied by 3 raised to the power of 3 minus 4 multiplied by 3 raised to the power of n divided by 3 raised to the power of n plus 1 minus 3 raised to the power of n. Okay, so the first thing to do is to express 2, 4, 3, 9, and 81 in terms of base 3. So for 81 is 3 raised to the power of 4 when expressed as a power of 3. Okay, so this will be 3 raised to the power of 4. Then we have n, so that will be 4 times n. So we have 3 raised to the power of 4n. That is when we apply one of the properties of exponent, that is power rule for exponent. That is a raised to the m, parentheses a raised to the m, okay, then exponent n. That will be equals to a raised to the power of m times n. Okay, so in this case, so we have 3 raised to the power of 5 minus 3 raised to the power of 4n multiplied by 3 raised to the power of minus 1. That is when we apply, if we apply the property a raised to the power of m plus n, okay, this will be equals to a raised to the power of m multiplied by a raised to the power of n. So that's exactly what we have here. So then for 243 is 3 raised to the power of 5. Then we have this over 3 raised to the power of 2 is 9. Then 2 multiplied by 2n. That will be 3 raised to the power of 4n multiplied by 3 raised to the power of 3 minus 4 multiplied by 3 raised to the power of n. Okay, then we can also write this as 3 raised to the power of n multiplied by 3 raised to the power of 1, then minus 3 raised to the power of n. So now let's factor out 3 raised to the power of 4n in the numerator, okay, for this one. So we're going to have 3 raised to the power of 4n square bracket 3 raised to the power of 5 minus 3 raised to the power of negative 1 plus 5. Okay, that is, if we apply this property, okay, then all over 3 raised to the power of 4n multiplied by 3 raised to the power of 3 minus 4 multiplied by 3 raised to the power of n divide by, now 3 raised to the power of n is common in this case, so let's factor out 3 raised to the power of n. So we have 3 raised to the power of n, then bracket 3 minus 1. Okay, so 3 raised to the power of 4n, we cancel 3 raised to the power of 4n. Okay, so this will reduce to 3 raised to the power of 5 will be 243. Then negative 1 plus 5, that will be 4. So the exponent of 3 will be 4. So for 3 raised to the power of 4, we're going to have 81 divided by 3 raised to the power of 3 is 27. Then minus 3 raised to the power of n, we cancel 3 raised to the power of n. So we have 4 over 3 minus 1, that's 2. Okay, so in this case, 243 minus 81. So 3 minus 1, okay, that will be 2. Then 14 minus 8, that will be 6. Then we have 1 left in this case. So this will be 243 minus 81. That will be 162. Divide by 27. Divide by 27. Then minus 4 over 2. Now, 162 divided by 27. That will be 6. Yes, that will be 6. That will be 6. 27 multiplied by 6. Okay, this is 42. Okay, then this is 12. 12 plus 4, so that will be 162. So which means in this case we're going to have this to be 6 minus 4 divided by 2. That will be 2. 6 minus 2, that's 4. So when we simplify the expression on the left hand side, okay, the value we are going to get will be what? Will be 4. And I just proved that this expression, when simplified, is equals to 4. And we've come to the end of this tutorial. The noblest pleasure. It's a joy of understanding.